Good morning, student. Welcome to School Cracker. And today I am going to consider the most important topic of the chapter, the indices. That is the fundamental laws of indices. And I wish after going through this lesson, students will be able to solve related to laws of indices. First and foremost, let us try to understand what is indices. If we consider an expression a to the power m. Here, anything, any number raised something, this raised portion is index, or it is sometimes known as power. So here we are going to deal with different properties of power. Let us consider another expression. Two a to the power m. In this expression, this 2a is the base and this m is the power or index. And in this expression 2a, this is known as the coefficient, while this is the variable. Now I hope all of you have understood what is index, what is power, what is base, what is coefficient, and what is variable. The first fundamental law of indices. Let us consider expressions x to the power m and x to the power n. If two numbers are getting multiplied, same basis, like here in this case x, and they are raised to some power m and n, then the law says the powers will be added up. Now whether it is true or false, let us consider an example. 2 to the power 2 and 2 to the power 3. Let us say, what is the value of this? By manually we can calculate this. It is 2 into 2 into 2 into 2 into 2. So that will give us 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32 answer. Now let us cross check using the law of index. So here the bases are same, 2 and 2, and the power is raised to 2 and raised to 3. So when the bases are same, the powers will get added up. So to the power 5. And yes, of course, this is giving us 32 as well. Here, yes, the answers are matching. That means this law is applicable. Let us consider another law of indices. So if the expression here is x to the power m by x to the power n, what will be the outcome? The law of indices says that whenever two expressions with similar base are divided, then their powers will get subtracted. So it will give us x to the power m minus n. Let us consider one example, a small number expression, 2 to the power 3 by 2 to the power 2. So what will be the result? It will give 2 to the power 3 means 2 into 2 into 2, while 2 to the power 2 means 2 into 2. So this will get cancelled, divided, this will get divided, and ultimate answer will be 2. Now let us cross check if this law is valid or not in different scenario when the bases are same. 3, 4, 3, 2. So what will be the answer? So it will be 3, 4 minus 2, that will give us 3 square. So that is 9. Yes, the answer is tallying. This means that here the law of division is also applicable. Different types of problem having similar bases. Another fundamental law of indices says, if the expression is given x to the power m to the power n, then if the case is this, x to the power m and this whole is raised to the power n, so then this power gets multiplied, x to the power m n. Now let us take an example. 2 to the power 2 to the power 3. So what will be the outcome? So these two powers will get multiplied in this case. 2 to the power 2 into 3 is 6. So this is the result. If any base is raised to negative power, then what does this signifies? This will give us the expression 1 by a to the power m. After this expression brought here, the sign of the power will get inverse. If it is negative, it will get positive. However, if it is positive, it will be negative. For example, 2 to the power minus 2. So this is nothing but it is 1 by 2 to the power 2. So that is giving us 1 by 4. Okay. Now, the final one. Fifth one. If any expression is raised to power 0, the answer will always going to give us 1. For example, if 1000 is raised to 0, the answer is always going to be 1. Let us consider an expression. Solve applying the laws of indices. The expression is given 2 to the power x plus 2 plus 2 to the power x minus 1 equals to 9. So here, once our approach should be very clear. In solving any indices problem, we always have to keep in mind that the bases should be same. Unless the bases are same, we won't be able to solve the problem. And after that approach, we are going to apply various laws of indices. Here the base on left hand side is 9. So we are going to convert this into 2 anyhow by applying various mathematical applications. So let us see. What does we see here? 2 to the power x plus 2 means, as law number 1, we saw that a to the power m plus n is nothing but it is a to the power m into a to the power n. Here we are going to apply this law. So 2 to the power x into 2 to the power 2. And here as well, 2 to the power x divided by 2 to the power 1. Now, in law number 4, we learn that any expression raised to negative power will give us its own base raised the inverse sign of the power. So we use this law in this step. So that is going to be 9. So what is this? 2x into 4 plus 2x by 2 equals to 9. So here we are going to find the LCM. So LCM will be 2. So it is nothing but it is going to give us 2x to the power x plus 4 into 2 plus 2 to the power x equals to 9, because the LCM is 2. Now we solve it. 2 to the power x into 8 plus 2 to the power x equal to 9 is 18. We cross multiply it. Now we take out 2 to the power x common. So what is left? X plus 1 equals to 18. So 2 to the power x equals to, this is 9. So we are going to transport it here. So 18 by 9. So 9 was a 9. 9 2 is a 18. Here comes 2. So ultimately our approach is fulfilled. So our goal was to make the bases same everywhere. So we had converted this 9 to base 2, and now the final step. Whenever the bases are same in two sides of the equation, the powers are equivalent. So x equals to 1. The final solution of x is equals to 1. This is how we apply the laws of indices while solving different types of problems. I wish everybody, those who are watching this lecture, will be able to solve and apply the laws of indices whenever solving this chapter. Thank you.